Hello students, we're going to start on lesson number 2 practice problems. So unit 2, lesson 2 practice problems, which is on page 143. So we're going to start out this first one. It says a large cheese pizza costs $5 each and a large one topping costs $6 each. Write an equation that represents the total cost of if you get C large pizzas and D large one topping pizzas. Alright, so when you go through and do that, you should receive T equals 5. Okay, remember that's $5 per cheese pizza, and C is the number of cheese pizzas. And you're going to add that to $6 per pizza for the one toppings, times D, which is the number of one topping. So that way the units cancel out. You'll get dollars here, you'll get dollars here, and T, of course, will be the total cost will be in dollars. So this next one, they have a lot of information going on here. Nothing in particular, but we're just going to go and walk through this. We'll read it, and we have to just find all the equations that could represent the quantities and constraints in this situation. Quantities and constraints. Okay, so realize that that's what the two things going on here. All right. So let's go and read this real quick. Jada plans to serve milk and healthy cookies to a book club meeting. She prepares 12 ounces of milk and 4 cookies per person, including herself. There are 15 people in the club. A package of cookies contains 24 cookies and costs $4.50. There is just a huge amount of information there, and it's very confusing. So just bear with this line of questioning for a moment. A 1-gallon jug of milk contains 128 ounces and costs $3. Let N represent the number of people in the club. M represents the ounces of milk. C represents the number of cookies, and B represents Jada's budget in dollars. All right. So select the equations that work. All right. So let's look through this. What are they trying to do here? Well, A is M. M is what? If you look back up through here, where do you see an M? Well, let's see. You got an N. We'll kind of circle these so we can find a little bit. You have an N, an M, a B, a C. All right. Well, M is the ounces of milk. So what they're trying to see here is ounces of milk. And it equals 12, right? So where did they get the 12 from? Well, they're saying 12 ounces of milk per person. So this is like M is ounces of milk. So ounces milk. So M is supposed to be, so they got M equals 12 times 15. So they're trying to say that the ounces of milk is equal to 12, which is 12 ounces of milk per person. So 12 ounces milk per person. And I'm multiplying it by 15, and the 15 is, do you see 15 anywhere? There it is. 15 people in the club. So 15 people or 15 persons. So persons cancels with persons. Ounces of milk equals ounces of milk. Yes, I could use that in some fashion somehow. So I'll circle that one. That one will work. We can use that for something. A portion of the total solution, depending on what you're trying to find. Let's look at this next one. They want you to say, well, 3M plus 4.5C equals B. All right, so let's look through this. So it's going to be 3. And of course, what's the 3 represent? Well, that's $3. Okay, so it's $3, but $3 for what? 128 ounces. So it's $3 per 128 ounces of milk. Realize that 128 ounces is better known as a gallon. So when you buy a gallon of milk, it's much more expensive now, but $3 at one time was a reasonable cost. All right, and times M, M being ounces of milk. So I'm going to multiply that by ounces of milk. Okay, so at this point, what units do I got? Well, ounces of milk and ounces of milk cancel, and so I got dollars so far in just this first part. Let's see what's going on here. 4.5. Well, what does a 4.5 supposed to represent? Okay, a package of cookies contains 24 cookies and costs $4.50. So that's $4.50 per, let's see, per 24 cookies, because that's what it says here. It says a package of cookies contains 24 cookies and costs $4.50. So $4.50 for 24 cookies. Now, could I have put down here packages? Yeah, I could have put on package, but I could also put down 24 cookies. It's essentially the same thing. And what am I multiplying that by? Well, C. What does C says? Represents the number of cookies. So number of cookies. So number of cookies and number of cookies, milk and milk cancel. So you're left with dollars plus dollars. So looks so good so far. And what's B supposed to represent? Represents Jada's budget in total. Okay. Says, and B represents B. Okay, so the ounces of milk and the ounces of, dollars that you spend on milk and dollars that you spend on the cookies. Well, this is great if you buy 1 gallon of milk and 1 package of cookies, but you're giving people 4 cookies and 12 ounces of milk. All right, and there's 15 people. So that doesn't represent the total budget, okay? That represents Jada's total budget. So this is really good, really close, but that's just the cost of a gallon of milk and a package of cookies. And we are very sure that we're going to need more than just 1 gallon of milk and 1 package of cookies for all these people. So while that starts off promising, it doesn't include the number of people that we have. It actually doesn't. It's not exactly what we need. All right. So I'm going to say no. That's probably not the best one. It's off by a little bit, just because it won't work out the way we need it to. 4n equals C. So that's 4. What does the 4 represent? Let's see. Do I see a 4 anywhere? I see 4 cookies per person. It's about the only 4 I see. N is the number of people in the club. So 4 cookies per person. We could think of that. 4 cookies per person. And then we say N is number of people. So number of persons. Number of persons. And C stands for the number of cookies. Number of cookies. Well, persons are going to cancel, so that's okay. And I'm left with the units of cookies and cookies. Yes, that one would work. That makes complete sense. All right. And we'll move on to delta. Delta says 4 times 450 equals C. All right, so 4, I'm going to only, I'll assume just like back here is 4 cookies per person. I'll say 4 cookies per person times 450. Well, what was the 450? Well, you had 450 for 24 cookies, $4.50 per 24 cookies. Okay. And what's that supposed to eventually equal? Which is C, and C being the number of cookies. Well, let's see. I got cookies and cookies that go away. And then I got dollars per person. Well, dollars per person is not number of cookies. So that one is screwed up. The units don't match. So I know that can't be part of any solution set. So, no, I don't like that. So I've crossed that one out. And then this last one, B, they have B equals 2 times 3 plus 3 times $4.50. All right, so let's walk through and see what this is. What's B supposed to be? Total budget. Okay, so this is total budget, meaning that's in dollars, equals. What's 2? What is 2 here? 2. Can I have a 2 somewhere? I don't know. But I know I got a 3 there. So maybe they're getting 2 gallons of milk. And the 3 would be $3 per gallon for milk. $3 a gallon. All right, here's milk. And I'm adding 3. And I don't know what the 3 is here. Let's figure that one out. They figure they need 2 gallons and they need 3 of these. $4.50 is $4.50 for a package of cookies. So I can have $4. $4.50 per package. So maybe this is 3 packages. All right. Well, this is your cookies. Okay, so packages cancel, gallons cancel. I'm left with dollars. I'm left with dollars, and I got dollars. So dollars plus dollars equals dollars. Does 2 gallons seem like enough? Yeah, 2 gallons should be enough for 15 people. And 3 packages. So let's see, it's 24 cookies, and there's 3 packages. Let's see, that's a 12, that's a 1, there's 72 cookies that means. And let's see, if you have 2 gallons, 128 ounces times 2, that's 256 ounces of milk. Okay, well, let's see. Each kid's supposed to have 12 ounces of milk, and there's 15 of them. So if I have 12 kids, each one, or excuse me, 12 ounces, I have 15 kids, and each one has 12 ounces. Let's see, that's a 0, that's 1, that's a 60, and 120, 180 ounces of milk. Yeah, you have more than enough milk there. You only need 180 ounces. What about cookies? It says 4 cookies per person. So if I have 15 people, and each one has 4 cookies, that's 60 cookies. And 72 cookies is more than enough. So why are they buying 3 packages? Because if they bought anything less, they wouldn't have enough. And the cookies can only be bought in units of packages. Milk can only be bought in units of gallons, or in 128 ounces. Alright? So that's why they have 2 gallons. So yeah, this is a good way to go and figure out how much the budget truly is on this, and you can do the math on this. Alright? And that's all there is for that one. Okay? So your correct answers here are Alpha, Charlie, and Echo. These are all good equations that you can somehow figure out how to use all this stuff on. Number 3. A student on the track team runs 45 minutes each day as a part of her training. She begins her workout by running a constant rate of 8 miles per hour for A minutes, then slows to a constant rate of 8.5 miles per hour for B minutes. So what does that look like? So let's draw a little graph. I like graphs and tables. They make things a little bit more sensical. So let's see. Student ran the track team for 45 minutes each day. She begins her workout by running a constant rate of 8 miles per hour for A minutes. So there is, let me draw this up. This is in miles per hour. So she's running 8 miles an hour, and she's going to go from 0 to A, and this is minutes. So she's running at 8 miles an hour constant for A minutes. And then she slows to a constant rate of 7.5 for B minutes. So she drops down and she's running at 7.5 miles an hour, all right, for B minutes. So this little distance here is B. So this distance here is A. This distance here in time is B. So here's the question. How much is this right here? Now a lot of people say, well, that's B. No. This distance is B. All right. I need to know if you started at 0 and you ran for A minutes and then you ran for B minutes, how long did you actually run altogether? Well, you ran, obviously, A plus B units. A plus B minutes. That's how long you ran. All right, so this is A, this is B. So the first part is A, and then you add B onto it, so that's A plus B. So that's what you should have in your mind of what's going on here. So they start out here. A student in the track team runs 8 miles, 7.5 miles an hour. Which equation describes the relationship between the distance she runs, her running speed, and miles per hour? Alright, so we got to do a little bit of explanation here. What do you got? Well, there's this equation that I commonly refer to as dirt. Distance is rate times time. Dirt. So distance is rate times time. Rate is speed. Now, if you've got more than one rate, more than one time, then you can expand this thing out into as many as you need. So here's for the first part, and here's for the second part. And you just simply add those two together. And that's the easy way to do this. If you have a third one, you can add it on another rate and time. But then you find your total distance as you do. All right? So what are they actually asking you for here? Which equation describes the relationship about the distance and her running speed in miles per hour? Okay? Well, here's the thing. Let's figure out what this is. I want you to just look and concentrate on this first part here. What do you see this as being? Okay, this looks a lot like a little rectangle. Well, how tall is the rectangle? Well, it's 8. How wide is this? Well, it's A. So if you're going to find, if you had a rectangle that was 8 units tall and A units wide, the area for that is length times width, which in here, this case, turns out to be 8 times A. So let's write that down. So distance equals rate, which is 8 miles per hour. And what's the time that we're doing? Well, we're doing A minutes. All right. Now they have written this specifically because now there's a massive problem that we have to do a very easy fix for. Miles per hour times minutes. Well, minutes and hours are not the same. They're both units of time, but minutes and hours are not the same. So what we're going to do is we're going to do a little cheat. Rather than saying it's 8 miles per hour, we're going to say that it's 8 miles for 60 minutes, which is the same thing as an hour. Now what can you do? Well, now I can go and get rid of the minutes. Look at that. Now, so what's that turn out to be? Well, 8 divided by 60 times an A. That's what you've got left. And the units, of course, are miles, which is a perfectly good unit when you consider distance is what it ultimately has. Now we do it for the second part. We do the same thing. We just consider this little block right here. And how tall is the block? How tall is this? Well, it's 7.5. 7.5. And it's 7.5 miles per hour. I'll just put the 60 down here for the 60 minutes. And then the time is going to be B units or B minutes. All right? So the same miles, hours, minutes, and minutes thing over here is going to happen over here. So what do I get? Well, I have 7.5 times B divided by 60. So now we take this and we look at all of our possible answers here, and which one closely resembles this. Well, if you see right here, this is everything we need to have. All right, 8 times A divided by 60 plus 7.5 times B divided by 60. Pretty much the same thing I got up here, and that's what equals D. All right. So remember that little trick. When they have minutes on one side and hours on the other, you can just cross this out. Now remember, 60 minutes is 1 hour. 60 seconds is 1 minute. So the question is, how many seconds are equal to 1 hour? So ask yourself that. All right? Well, the answer is 3,600. There are 3,600 seconds in 1 hour because you have to multiply the 60 and the 60. 60 times 60 is 3,600. So always remember that. I'll always ask. I even ask seniors on that in Syria.